So we have spent three videos describing motion, but never asked the big question: what actually makes things move, stop, or change direction? So the answer is force. And one man, Isaac Newton, summed up everything about force in just three laws. So by the end of this video, those three laws will feel like common sense because you see them every single day without realizing. So, so we'll be talking about Newton's laws of motion in this video. A force can be a push or a pull. You can see on the screen that there is a block lying on the floor and a person is applying force on the block. So he's pushing the block. So this is a push. And let's say if he's applying force on the block from this side, he's trying to pull the block. Both of them are force, but this is a push and this is a pull. So a force can be a push or a pull. A force can start, stop, speed up, slow down, change direction, or even can change shape. If the forces are balanced on an object, there will be no change in the motion. But if the forces are unbalanced, there will be change in motion. Now, how an unbalanced force changes the motion, we'll learn next. Now, we have first law of motion. So there are three laws of motion. We'll start with the first law of motion. So, the first law of motion says that an object won't change what it's doing on its own. A still object stays still. A moving object keeps moving straight until a force changes it. That's very important. Until a force changes it. So an object will be in a state of motion until a force changes that motion, or it will be at rest until a force changes that motion. So the resistance to change is called inertia. So I'll explain that with an example. There is a glass and there is a card resting on the glass. On top of the card, we put a coin. Okay. Now let's say if flick the card away at a very fast speed and the coin doesn't fly it with, its inertia keeps it in place. So in this example you can see that we pulled off the card from its original place and the coin falls in the glass. You can try this at home and you will see that the coin will slip down the glass. Why? Because the card wanted to move in this direction because we pulled it with extreme force, but the coin had inertia and it wanted to resist that motion. The coin did not want to move in the same direction. It was staying at rest, so it wanted to stay at rest, and hence it dropped down. So this is what the first law is. A body in at rest will stay at rest, or if it is moving, it will keep on moving unless a force is applied on it to change its motion. Okay. Now there is a second example. It's a very classic example. Let's say you are in a bus. This is a bus, okay? And let's say this person is in a bus. And let's say the bus suddenly stops. What happens? I'm pretty sure you observe this in a day-to-day life. If the bus stops, we usually feel that we are going in the direction, forward direction, in the direction in which the bus is moving. Why is that? Because we were moving with the bus, so we were in motion. Now the bus applies brake suddenly, but since we were moving, our inertia wanted us to move. Okay, it was resisting the motion of bus because when it stops suddenly, your body jerks forward because your body wanted to keep moving. That's the first law acting on you every day. Okay, and it's the same. Let's say if the bus was at rest and you were also at rest, if the bus starts to move suddenly, then since you were at rest, your body wanted to be at rest because of inertia, and you feel that you feel a jerk backwards. So that's because of the first law of motion. Now you know the reason, right? Now it means the more inertia you have, the harder to move or stop. The inertia is stopping us from the motion, right? inertia stopped us from stopping as soon as the bus stopped, or the inertia tried to stop us from moving when the bus suddenly moved. So that's inertia. The more inertia you have, the harder to uh, move or stop. Basically, the harder to change the motion. And inertia is directly dependent on mass. The more mass you have, the more inertia you have, and it becomes harder to change the motion. Okay. Now, the second law. Now, the second law gives us the most important formula in this chapter, which is force equals to mass into acceleration. So, the heavier the object, the more force you need to accelerate it. Because if the mass is more, and you if the mass is more, you need more force to have the same acceleration. F equal to ma. The unit of force is Newton, and so 1 Newton equal to 1 kg into 1 meter per second square. So let's say we have a light box of small mass m, and let's say we have a heavy box of big mass m. Let's say the force applied on both of the boxes is same. What will happen? As per this formula and as per what I said just now, the mass of this block is less and the force is same, versus the mass of this box is more and the force is same. What will happen? Mass into acceleration is force. So the force in both of the cases is same. Mass, so the case with more mass will have less acceleration, right? And the case with less mass will have more acceleration because the force is constant on this side. So if so the force to put it in numbers, let's say if the force is 10 Newton and the mass of the lighter box is 2 kg, what will be the acceleration? The acceleration will be 5, right? 10 by 2 is equal to 5. So the acceleration in this case will be 5. But let's say if the mass is 4 kg of this block, what will be the acceleration? The acceleration will be 10 by 4. It will be 2.5. So the acceleration of this block will be 2.5 and of this block it will be 5. So the lighter box with the same force will have more acceleration and the heavier box with the same force will have lesser acceleration. So that's the second law of motion. Same force, less acceleration for more mass. Okay, so basically the more mass you have, the more inertia you have, because the more mass, less acceleration. Basically, your tendency to stop is more in this case. So basically, all the laws are also interrelated. Okay, now we'll move to third law of motion. The third law of motion, uh, it's the famous one. Okay, so for it states that for every action there's an equal and opposite reaction. Forces never happen alone, they come in pairs. So if there is an action by one object on another object, there has to be an there has to be a reaction from the second object on the first object. So that's the third law of motion. React, there will be a reaction to every action, and it happens in pairs. So that's why the forces comes in pair. Okay, if I have to explain it with an example, I'll take an example of a balloon. Uh, this is an example of a balloon. Let's say I think it's very common. You might have observed it already. Uh, you fill in a balloon with air and you let it loose. What happens? You feel that the air is coming out of the balloon, right? But why does the balloon move in the opposite direction of the air? Because the air is coming out. There is a thrust of air in this direction, so it pushes the balloon in this direction because there is no external force on this system, right? So the forces needs to cancel out because there is no external force. So external force has to be zero. If the if the thrust force is on this direction, and let's say if the force on the balloon is also in this direction, then the forces will add up, right? And there will be a net force on this system in this direction, which is not possible because there is no external force on this direction. It's because there is no external force on this system. So the thrust of air is in this direction and it will push the balloon in this direction. So the action is that the air is pushing it pushed back in this direction, and the reaction is that it pushes the balloon in this direction. Okay, so this is because of the third law of motion, and these two forces will cancel out each other, and this is exactly how rockets fly. You might have seen that they push a thrust of combustion fuel uh, towards down towards the gravity, and then it pushes the rocket in the up direction. right? So that's action reaction. Uh, Another example I'll take is again daily life example. When you move, what we do? So when we move, we all know that there is friction, right? What happens when we move? So when we move, how do we press the foot? We, if you observe it, we try to press the foot towards the fingers, right? Um, and it's basically like we are pushing the ground backwards, right? And then we move forward. So what happens? We are pushing the ground towards the back. We are pressing the ground hard towards the back. So that's the force from the foot pushing ground backward, right? And what happens then we move forward. So it's the ground which is making us move forward by applying an equal force as a reaction to the action which we applied on the ground. So that's an action reaction and it helps us move every day basically. Okay, so that force is called friction, but we'll come to it later. But for now, it's important that we know that okay, we apply actionary force on the ground in the backward direction, and ground applies reactionary force on us in the forward direction, and that's how action reaction works. And third law works in this example. Okay, so you basically you are using third law of motion with every step you take. So since action reaction act on different objects, that's why they don't cancel because the action in this case the action is on the air and the reaction is on the balloon. Okay, but so they cannot cancel because if you look at balloon as an object, individual object, there's only one force acting on it, and if you look at as air, there's only one force acting on it. Similarly, in this case, if you look at ground individually, there is only one force acting on it in backward direction. And if you look at person individually, there is only one force acting on the person in the forward direction. So they cannot cancel. But if you talk about system, these two becomes internal force and they have to cancel because there is no external force, so it has to be zero. It has to cancel. Similarly, in this case, okay. So that's a very important statement that the action and reaction act on different objects, and that's why they don't cancel. Okay. Uh, let's move to an example. So this is an example. Let's say a force of 20 Newton acts on a 4 kg box. Find its acceleration. So what will be used here? So we have a force and we have the mass of the box. So it's I think it's straight from the second law of motion, right? What does it say? It says that F equal to ma, right? It says that F equal to ma. So we have F and we have m. We can get a, right? So 20 by 4 is 5 meter per second square. So it's very simple. Okay. So here's a practice question for you. Uh, so what force is needed to give a 5 kg object an acceleration of 3 meter per second square? So let me know your answer in comments. I think it's a very pretty simple question, and it's again a different way to ask what we solved before this. Okay, so let's do a recap. So we studied three laws of motion. The first law was the objects resist change, and that change resists, and that resistance of change is called inertia. Second law we studied was F equal to ma. The third law we studied was that action is equal to the reaction and in opposite directions. Okay, so these are the three laws we studied in this video, and I think this will help you in understanding the concepts of laws of motion. And yeah, do let me know your questions and comments. So we'll meet in the next video, and please like and subscribe for more such upcoming videos. Thank you.